Today we're going to be doing a recording of an interesting topic called process or automation data collection. And the idea is that we want to dive in and talk about the value, why you do it, and how you do it for data collection on the shop floor in a manufacturing environment. So I have this little presentation here called Automated Process and Shop Floor Data Collection. And in this presentation, we're going to talk about 4 key aspects. Number one, what data is there? 2, and probably this is the most important question, why? Why do I want to collect data? 3, where is it used? How do I use that information? And you'll see that in some cases, information is used right now from the shop floor for reporting, and in the future, there's other uses. And then lastly, how does it work? How do we actually collect data? And I'll talk about both manual and automated ways of collecting that data. So what is it? So what are the different classifications that fall under data collection? The first and very most important is collection of real-time or near real-time data from machines, operators, and independent sensors. So the idea is that the data is coming from the shop floor in a real-time manner or a near real-time manner. And why do I say real-time versus and near real-time? Because we also can collect the data after the fact. In other words, if I am running a production order on the shop floor, I'm making a part, and that production order, as I complete the order, I record how much material I use, or I record some measurements in terms of quality from the part that I'm making. I can store that data in the production order, and then later on next week or next month, I can pull up my production order and look at that information. That's not real time. That's not near real time. That's stored data and often ignored data. So the idea is that by collecting data real time, in other words, as soon as the operator puts it into the system, it becomes available. It changes the value of that data. Now I can use that data for instant decisions or future analysis, but I could use that data for instant decisions. And near real time usually means that even if it isn't instantly available, it's available by the end of the day or pretty rapidly, maybe by the end of the shift. So it can be collected and stored and then used within a day or two pretty rapidly. So any of this data that is collected, we call it shop floor data, and I'm using the word shop floor very sort of generically. A lot of the examples I'm going to give come from a discrete manufacturing world where I'm making pieces and parts or building machinery, because that is a big part of my experience, but it also includes manufacturing of all different sorts. For instance, if you're making pharmaceuticals, you might have giant tanks and reactors and pumps, or food manufacturing. You would have giant machines producing buns or making hot dogs or all the things like producing candy bars. So there's a lot of different kinds of shop floors. There's everything from process manufacturing, continuous manufacturing like the oil and gas industry, where I've got giant pipes and real-time through process reactors, to a small manufacturing shop where I'm making one part at a time on a bench. All of that is considered shop floor. And the data falls across many categories. It's historically, the most common bit of data is quality management data, where as a matter of testing that part, of making sure that part meets my customer requirements, I measure it somehow. I measure the quality, I take a sample, and I run it through a machine to make sure it's got the right pH or the right color or the right elasticity or the right length, or whatever it is, whatever kind of part, chemical or product that I'm producing, I measure somehow. But we also traditionally also measure production planning information, like when did I start that part? When did I finish that part? How long each step to produce that material took? How much inventory I used to create that part? And then lastly, and most often disconnected, is maintenance data. How did my machine run? Did it run hot? Did it run cold? Is there vibration in my pump? Are all these things associated with how the machines and the pumps and the tanks run? Can that be collected too? So it's a lot of different kinds of data. And I mentioned down here at the bottom, timely data provides an opportunity for production planners and schedulers. But only if they are driven by management and they're prepared to make these changes and have a process to make these changes based on real-time data. So why is collecting data important? Why is automating that data collection important? Obviously, automating it reduces the workload of writing things down manually. I've been in a lot of shops where the plant manager didn't trust automation, and so he required all of his operators to scribble things down on charts and then hand them in to be reviewed and, I guess, data entered into a spreadsheet so he could look at the information. Whereas he had perfectly usable automation techniques to collect this data for the operators automatically. But he didn't trust stuff, so he wanted everybody to do it manually. That is a huge waste of time, and it introduces new errors in the process. So by having data collected automatically, you increase the accuracy, timelessness of the data, and you allow for more data to be collected for some future value. I'm not going to go through all these in detail. You guys can read this slide at your own pace. This slide is available on D2L for you to look at. Where is this information used? Typically, it's manufacturing control, right? This control allows the operators to communicate to their schedulers, the people running the plant, information so that the people running the plant can run the plant better, like delays, if there's a problem with the production order. It gives them feedback to know how long that product really takes to make, what materials were used. All this is very, very important if you're going to run a plant smoothly. If you don't know what materials are being used, you will run out of materials and you have to stop your production. So you always want to have a good, accurate count of what's used. And lastly, I think from a customer visibility standpoint, and this is the growing area, customer visibility gives that customer a sense of power over what's going on the manufacturing floor. If we're talking about custom manufacturing operations, which is a new and growing schema, especially if we're talking about lean manufacturing where one piece flow is the objective. Obviously, plant reporting is very, very important. Plants are run by bean counters, run by the finance department in many cases, so they always want to know how much money they're making or losing. And lastly, quality data and maintenance data. We talked about those already. So the last thing I want to talk about is, very briefly, how does it work? And it falls into 4 categories. There's the old school way of manual entry, and traditionally this is paper sheets. And this is where the near real time comes in. Paper sheets then can be handed off to some secretary or data entry clerk who will then enter that information into a computer, usually a database. Usually it goes in there and is ignored. Now we have new, slightly more modern computer or tablet-based applications that allow the operator to type right into the tablet at his workstation his real-time data when he collects anything: production order information, times, material used, quality data, maintenance data. A new growing world of quality instruments. We have a lot of quality instruments that are out on the shop floor or in the quality department. Those instruments are integrated in many cases, either integrated or semi-integrated. That means you can hook up a Wi-Fi cable or a USB cable to that machine and have it communicate to a computer and send that computer it's programmed to do so, the information that it collects. So you can automatically store all sorts of quality information about the analysis or the measurement that that machine is doing. You have some very big fancy quality machines out there, ones that can move around a part and measure 10, 20, 50 different measurements on a part and then store that information. Those machines are getting smarter and smarter and can be hooked up to databases and then used for reporting afterwards. Manufacturing machines are getting smarter. A lot of shop floor automation is occurring, and these packaged machines, these milling machines, these lathes, these automatic reactors, curing machines, all these machines are getting better and smarter and capable of communicating to other environments, and therefore you collect data directly from those machines if you know how. And this is the challenge. Knowing how to communicate to these machines can be challenging. A lot of times different major manufacturers of machines have their own custom interfaces that you need to buy from them, or use a third-party software vendor and buy from that third party the software integration tools that let you hook that machine to your database. So it can be very expensive, but it's also very powerful and saves a lot of time and money of collecting data otherwise. And third, and probably most interesting for you guys as people just entering in this world, is there's a vastly growing number of independent integrated data collectors. These are very low-cost microcomputers that can be hooked to low-cost sensors and hooked to the internet. And then they can be hooked to a broad network of devices. This is the thing we call Internet of Things. These small, intelligent devices that can independently collect data from anything. All you have to do is plug them in somehow, hook them to Wi-Fi, and now they can collect data for you. And all you need is the right software to go get that data and pull it together into a database that you can report on.